Schematic-driven layout (SDL) is a powerful feature in Siemens Custom IC design tool that generates layout directly from the schematic. Starting with 2024 version of the Custom IC tools, a new SDL with ECO flow was introduced. They will be demonstrated in Schematic Editor as Edit and Layout Editor Edit. The new SDL with ECO feature allows users to either generate the entire layout or perform pick and place of selected components. It supports cases where the schematic and layout are located in different libraries, named differently, or have mismatched hierarchy. It also enables cross-probing between schematic and layout, displays fly lines, and helps identify and resolve mismatches between them. The SDL flow begins by creating a layout from either the schematic editor as edit or the layout editor edit. Components are placed onto the canvas, and once all devices are in position, they are interconnected using flying lines. After placement and routing, design rule check DRC and layout versus schematic LVS are running using the Calibre physical verification tool. These steps are repeated for each new block until the design is complete. During a design cycle, the schematic may change after the layout has already been generated, which leads to mismatches between the layout and schematic. In such cases, an ECO engineering change order process can be run which generates two reports, the ECO report and the differences report. The differences can then be resolved automatically or manually, or marked as waived or ignored depending on the situation. Then, recheck the layout and proceed with the flow. Click the L button to launch Edit and open the new view window. Select the target library, enter the cell name and view name. Select the logic source that will be associated with the layout. The layout is now generated. Go to SDL browser. All devices can be generated by clicking Generate All, or Pick and Place. Pick the devices by clicking them on the instance list and place them in the canvas. Next, connect the devices. Go to the net list, pick the nets, right-click and select Show Flying Line. With the flying line enabled, connect the terminals with the interactive router. Cross-probing is a feature that highlights corresponding instance, port, and nets when they are selected in the layout, schematic, or SDL browser. It is useful to interactively explore the design for checking. With the Sync button on, select the device and click the Cross-Probe button in SDL browser. M1P is now zoomed in and highlighted in Edit. Another example, select a net in Edit. All the elements in Edit that belong to this net, such as the terminal, root, and the flying line, are highlighted. For hierarchical instances, each higher level instance can be expanded, and its lower level devices can be placed on the canvas. This provides high flexibility during the design. The white icon of the devices in SDL browser indicate that they are flattened. These flattened devices are still SDL compliant. Features like flying line and cross-probing can still be applied. Run ECO extracts the schematic information, compares it with the layout and generates reports. ECO report is useful for tracking the history of design change, while the mismatch can then be fixed in the differences report. For example, change width of M1P to 10 micron. Rename M2P to M2P new. Add a new device. Go to SDL ECO browser, run ECO. Reports are generated. First report is in the SDL ECO browser. It captures the difference between the modified logic and the last logic that used in the SDL browser. The run session indicates that how many ECO has been run, serving a history log. Apply the filter to view the most recent run only. In this example, M2P is renamed to M2P new. New logic M5P is added. M1P's parameter width is changed to 10 micron. Another report is the SDL differences. The SDL difference report compares the layout and the schematic directly. In this case, in addition to the above changes, M4P is also reported as missing in the layout. This report is also where the mismatches can be fixed. Select the entry and click Fix. M1P width is now fixed to be 10 micron in the layout. Mismatches can be waived or ignored. Waive only apply to this check only, while ignore skip future checks for the same issue. For missing device, fix it by pick and place to the canvas. It can be marked as manually fixed to indicate it has been addressed. Then run recheck layout to verify the updated layout. SDL streamlines the layout creation process by tightly integrating SEdit and LEdit, enabling efficient design generation, verification, and updates. With support of flexible design structures and powerful ECO handling, it enhances productivity and accuracy throughout the custom IC design flow.